So you have had many PhD students, including some from IIT Bombay, and all of them are faculty members at reputed institutions, and they are working in different mathematical fields. And you have had lots of collaborators in India and abroad. How did that come about?
Firstly, I don't know if you can really say, I mean, let me first come to the issue of collaborators. I wouldn't say there are such a lot. The major collaborations, of course, with Margulis, about which we discussed, and McCrudden, there were specific area, specific, problem, in fact, in the case of the embedding problem, which motivated the collaboration. Similarly, I have had collaboration with Arnaldo Nogueira, with whom, we have, this is one of the lucky things that I could visit France more or less every several years more consecutively and so on, and we sort of developed a bond and talked to various things, and in particular the idea of continued fractions is something that's common to us that developed. So other than that, of course, I have had collaboration with several papers with you. But other than that, the other collaborations have been incidental in some way. I mean, it's not so. So for instance, when I was at the first overall FAH conference I attended, there was Michael Keane was also one of the participants, and there was some problem about invariant measures which are not locally finite. We always keep talking about locally finite invariant measures, but not locally finite. Is it possible? And then it turned out that after Oberhof, I was going to go to Rennes, which is where he was at that time. And in the course of the 2 weeks, we could find a solution. So that was one paper. So then at one time I had another collaboration with Bernarditi, which on a specific topic about so on. So there are various. It's probably not worth going into the whole list. So there are incidental collaborations. So when some question comes up, you have the problem. You have something to contribute, and then it works, and then come up with a paper. So, the other persistent collaborations have been limited, which we discussed. And we didn't discuss the collaboration with you as such, but that's I think that's kind of understood.
So, is it fair to say that a lot of these collaborations come out of having an open mind and discussing mathematics with a lot of people without necessarily any end goal in mind, just open-minded, open-ended discussions?
Right. Also having a deep knowledge of different areas of mathematics.
Different areas, right. Then students, of course, we had by then we had a graduate school, and then students needed to be guided, and then it was not always possible or convenient or desirable to get everyone into homogeneous dynamics. So, and then I also had acquaintance with various things. So, for instance, work with McCrudden led to related questions, not necessarily about the embedding problem, which was sort of convenient for many for PhD studies, and so that started. Then there was one student. She had in fact studied harmonic analysis, and halfway she had to quit from there are some problems with the guide, and she had to leave, and then she studied with me. So I looked into what she had studied and found something convenient for her, so something like that. So there are various kinds of that sort of accounts for divergence of areas. So sometimes depending on the need. Then also one of the other things, the problem that I chose for Mira Mindker, that is something, it turns out that it has attracted quite a bit of citation. So though initially it came to me as a simple, I remember it when I was at Chicago, I was wondering what to do and so on. It just occurred to me that there was a question of whether about nil manifolds admitting Anosov automorphisms. So that, and the available results were kind of limited. There was the paper of Auslander, and I had done something, but it seemed to me that there must be more flexible ways of doing that, and that's when I introduced this idea of associating graphs. I mean, nilpotent algebras associated with graphs, and that idea has again taken off, and not as much as the other things, but that Anish has mentioned. But nevertheless, I mean, there's quite a few people I find following up the idea of manifolds associated with graphs in the way that we did. So again, going back to Anish's comment, keep an open mind. You look at various things, so some various things work out. I mean, not.
But it's amazing that you have managed to mentor all these students in a different area. Each of them you gave different problems, and they are now successful mathematicians, though they are all your students, not different faculty members.
I'd only say thank you. I mean,
so coming back to your honors, you have been honored many times by national and international awards, fellowships, and recognition. Any memories associated with them?
I don't know. I have a few honors. I mean, I don't think so. The Bhatnagar Award, which is mentioned. So when I got it, I was at Göttingen, and so when I mentioned to one of the neighbors, I mean, it was it's the colony where many scientists and academic people lived, and this was a person from India. So about the award. So he asked, when did you apply? And I said, no, one doesn't apply to this to these awards. This is just a recognition, nominated by others and so on, that I was happy. And so, yeah. And then the TWAS award, the World Academy of Sciences. So about that, the thing I recall is that this was awarded at a conference in Mexico, so at the Mexico City, and it was an interesting award ceremony, and it's not. By the way, when I got the Bhatnagar Award, it's usually received at the hands of the Prime Minister, I think, but I was not here, I think. And then it was when I had gone for some regular meeting of involving CSIR, that's when there is somebody handed it over to me, somewhat ceremoniously, the committee clapping. And so
did they also give you the traditional bouquet of flowers?
Pardon?
In the Bhatnagar, they give you a bouquet of flowers as
book?
Flowers.
I don't remember.
So can I, drawing again on our discussion on your prominent role in homogeneous dynamics, can I now fast forward to the year 2009-2010, where for the first time the International Congress of Mathematicians was to be held in India, in Hyderabad, and you had a very prominent role, organizational role in the event, as well as what one could say is, one of the Fields medalists was, you could draw a direct line from your work to Lyndon Strauss's work. So that must have been a very satisfying occasion for you.
Yeah. In fact, so many of the Fields medalists, this is associated in some way or other with my work, Margulis, then Lyndon Strauss. Even Kurt Macmillan, for instance, has a version of my the Schmidt game modification.
That's correct. That's true.
So
Yes.
So I mean,
Absolutely.
many of these people.
And so does, and one should also say that Akshay Venkatesh is also. Akshay Venkatesh also.
Yeah, Akshay Venkatesh. Yeah.
So can you tell us a little bit
about? I suppose Yokos might have some things I don't know.
So can you tell us a little bit about the ICM and how it was for you?
ICM?
Yes.
Actually, at that time, I was the chair of the National Board for Higher Mathematics. We have not talked about that, but initially, I mean, the idea was mooted. I mean, ICM was mooted when still Raghunathan was the chair, but I took over in 2006, I think, and 2010 was the ICM. So there was a lot of planning, etc., had to be done. But I mean, it was all committed. It was all teamwork. So I was presiding as the chair of NBHM, but it was all teamwork. And in fact, for the ICM itself, we had a separate structure with Raghunathan as the chair. So and he. I mean, he had enormous capacity for organizational things like that, so which was really responsible for the success of that. It was good that we got such a large international audience at one place here, and that's something notable. But I must say, I am not sure I had any significant role as such beyond the teamwork. I mean, it's not.
So. NBHM, the National Board for Higher Mathematics, organizes activities and supports activities to promote mathematics research and teaching in India. Can you please elaborate more on the role you played in NBHM?
Yeah, I think NBHM is really one of the good things to happen to Indian higher mathematics at that level. So. Say 83, 84, sometime it started, and so among the various things, apart from support to various libraries, which has worked sort of life-saving or sustaining role for many libraries around the country. That's something we have been able to manage. Then the support for various kinds of conferences, events, and apart from these predictable things in some way. I mean, that any funding agency would probably have to do this. The Olympiad activity is one of the important things. I mean, the Olympiad, the successes have seen ups and downs, but I think the sort of maintaining the tempo has been very important, and that has where there NBHM has played an important role. Then supporting activity like the MTTS, which is actually not just not just recognizing talent, but grooming students on a massive scale. And of course, the main driving force there was Kumaresan. But I mean, the support of NBHM and more or less at the level always that he needed was something very important that was achieved. Another thing I am personally sort of more attached to is the Madhava competitions. So the early Olympiads have, I mean, they select talent, and then of course, but that's sort of limited to school level. And in India, we didn't have anything like, I mean, the US, they have the Putnam and so on. And some of us had felt the need. And fortunately, at that time, the Sholapurkar, VM Sholapurkar from SP College, Pune, through his college had made a project. Actually, that was the project was meant to be for a 1 year thing, etc. But we encouraged them to sort of continue with that and give a structure, and then we even gave it the name Madhava Competitions. The project didn't come with that. So, and I think that has really caught on, and it has generated a lot of interest in mathematics at the undergraduate level. And I have had more continuous association both with Olympiads as well as this Madhava competition, not so much with MTTS, of course it's a close program to be run in a certain way. And I quite enjoyed not just how it was progressing, but the outcome. I mean, I think that it's something to write in your history books. I mean, about as a major thing that happened during this period and so on. So some of these activities, I think, and apart from this, we of course supported various institutions like CMI. CMI has always had its financial problems. I mean, it's kind of somehow nobody's baby in the government, and so, but through NBHM, it could be sustained to quite an extent, and then we supported like Bhaskaracharya Pratishthan, then the Bhuvaneshwar, National Institute,
IMA.
Yeah, and so on. So some of these were also, I mean, crucial for various developments. I think.
You also took initiative for the library grants to various universities in India.
Yeah, the idea of library grants were there, but I think during my period we did manage enhancements to systematization in various ways. So, and encouraged new centers to come up with proposals. And
perhaps we could ask you a little bit about another of your serious interests, which is in the history of mathematics.
History of mathematics, yes.
When did this begin? And
yeah.
So let me briefly go back to the beginning of our discussion, where you were telling us that you were very traditionally minded as a child. Did this persist into youth and adulthood?
My childhood has a certain association with that, in the sense that it was because of my traditionality that acquired some knowledge of Sanskrit. I did some courses in there's the Tilak Maharashtra Vidyapith in Pune, which used to have these exams for courses, and in various places I had some teachers who would prepare their students, and I had joined one such. I did two exams too, so sort of 2 units, let's say. So that I mean, it doesn't mean that I can acquire this fluency to speak, etc. But I have fair degree of familiarity with the language. I mean, so when I read things in Sanskrit, I may not be able to make out the exact meaning, but I get a sense of something that's there. So that in that sense, the childhood association with traditionality did help. But the actual association came in a sort of different way. I think there is something called the Indian Society for History of Mathematics. This was founded in 1979, soon after the 1976, which is Aryabhata's 1500th anniversary, which was celebrated, and that's how we had this Aryabhata satellite and so on. So at that time, there was some enthusiasm about that, and some of the people established this Indian Society for History of Mathematics. And around the beginnings of this century, Professor B.S. Yadav from Delhi University was the chair. There was the chair or president, whatever you can say. So, and he somehow got to know that I have some interest in history and so on. So, and he got me interested in joining the society and invited me to various conferences they had. So, the earliest, I think, is when in 2001 or 2002, something like that, there was a conference in Kerala where I spoke on the history of in a history conference, so to speak. So before that, I had familiarity with the Shilva Sutras. Shilva Sutras, as you know, are the ancient compositions on geometry. They're associated with how the making of the Vedis, namely altars and fireplaces, the chiti or agni as it is called. And these are actually, unlike the fireplaces that we see in the current weddings, Hindu weddings and so on, they are very elaborate affairs. I mean, you used to cover a huge area, 100 feet by 100 feet and so on. And they used to have intricate figures like the turtle or a falcon and so on with stretched wings, and because of various metaphysical associations that we need not go into. But the point is the sort of the scale of this thing, scale of the activity generated the understanding of the geometric principles, various geometric principles. So for instance, in particular, one of the notable things that one should say is the what is called Pythagoras theorem has been explicitly stated in the Shilpa Sutras. There are actually 4 major Shilpa Sutras have been studied, say, for over 150 years now. This major study in the modern framework started in 1870 or something around that time. And so the apart from, so there are various how to construct a perpendicular. The word perpendicular itself did not have an analog, but the various constructions involve producing a perpendicular, and that is acquired. And there was also they were also engaged with the issue of interrelating the circle and the square. So, or what one would call in the classical Greek style, is called the squaring the circle. Circling the square and squaring the circle. So, here the methods were of course approximate. They are not concerned with straight edge and compass, etc., like the Greeks, but the more practical issue of how to get circle with the same area as a square and the other way, and approximate constructions would satisfy that. That's how it was. And so in the course of that, I'll not go into more details, but in the course of that, actually they even found a value of approximate value of square root of 2, which is quite impressive. I mean, it's accurate to 5 decimals. My first talk in this was actually on not on the Shilpa Sutras as a whole, but a very specific thing, the Pythagorean triples. I mean, like we have these triples 3, 4, 5, 5, 12, 13, where the squares of first 2 terms add up to the square of the third one, and that's important and interestingly, at the Shilpa Sutra times, the Vedic times, this was used for producing right angles. So if you have a triangle for which this property is satisfied, then it would be a right angle triangle. So therefore, that gives you a way of producing a right angle. And this was extensively used in the Shilpa Sutras. That was okay. My first talk was only about the Pythagorean triples and what role they played in the Shilpa Sutras, and that was actually published in the Current Science. So it was. Something on record. So subsequently I got interested in more detail of that, and I was also continued to be associated with the Indian Society for History of Mathematics, of which in 2008 they made me president, and which I continued until I think 2019 or so, something like that. And during the period, of course, we had these annual conferences, and I had to, as president, I had to was committed to do my bit, so in some way. So some of that happened more out of the necessity of the position, but some of it out of my interest. So in the meantime, there are various papers written. I think I have numerous articles on and interest. One interesting thing that I might mention is that one of these was actually translated into Russian and published in a Russian magazine.
That's fascinating.
This before the English version came. So, So, and then even now, in some way, my main topic of study in some way has been the Shilva Sutras, but over the years I know various aspects of the Indian, ancient Indian and later medieval mathematics, Aryabhatta, Brahmagupta, Bhaskara and all. So because after participation in these conferences and studying things for their own and so on, so that has continued.
So apart from research and teaching, Professor Dani, you have had an important role as an editor of several international and national journals. Would you please comment on what role you had?
Contributing to editorial boards and as editor is one of the important academic aspects. Our accumulation and transmission of research knowledge is in terms of journals, and then it's important that keep track of the activity in a perceptive way. It's important, therefore, that I think people need to involve themselves, and though it takes one's time in some way. And so I sort of liked the part to play the role in spite of the activity, and in some way I felt it's something in me, within me, that to be the editor. You have a certain sense of aesthetics about what should be done, what should not be done, and both in terms of, say, not just way of saying things, but also how to organize things, etc. And then some of that, it was interesting to try and put into practice in some ways. This is not, not quite as board of, member of editorial board. Member of editorial board one is more, I would say, in a more routine sort of way. If some people feel that you should, the group of people who already are there, they feel that you should join, then you invite you, then you join and you do your bit. That I have done for various journals, which including ergodic theory of dynamical systems, a journal of theoretical probability, and some others also. But taking the leading role happened in case of the proceedings of the Indian Academy of Sciences, of which I sort of ran for a dozen years, from 87 to 2000 or something like that, and bringing out special issues on Ramanujan, for instance, and things like that. Similarly, for the Indian Journal of Pure and Applied Mathematics, I have some special volumes were produced. I also happen to be now at the editorial boards. About for the history part also, it was initially for the ISHM, the Indian Society for History of Mathematics, started a bulletin of its own, more or less at its inception. So and there's one renowned Indian historian of mathematics, R.C. Gupta, Radhacharan Gupta. He was the editor for several years. Actually, incidentally, he was he's the awardee of Kenneth O. May Prize, and I would say it's sort of to that topic. It corresponds to something like the Fields Medal for mathematics per se, and he's one of the awardees of that. He ran the journal until 2007. So maybe 2005. Okay, and then it was taken over by Professor Yadav, whom I mentioned in connection to my introducing. He was the editor for 3 years, but he was an old man, and I think he was not quite able to handle the thing. So he asked me to take over, and then since the actual editorship was taken in 2010, but the volumes needed to be, the backdated volumes had to be produced with effect from 2009. So I am now in the 14th volume of that. So getting articles, getting them sort of regulated by referees and so on. This is something which is I enjoy, though of course not how successful it has been. I think maybe the judgment should be left to others in this case.
You were always interested in how to write things well.
Yeah. So when I said
It's
in me, I meant that I always have this sense that something is said, then it should it should be something else. So
how to communicate efficiently.
Right. Yeah.
So after retiring from School of Mathematics, TFR, as a distinguished professor in 2012, you were a visiting distinguished professor at IIT Bombay, and currently you are a chair, or rather the chair of UMDAE Center in Basic Sciences. You are a chair of the mathematics part, which is housed at Kalina campus of Bombay University. And you are also teaching undergraduate students there. So, do you have any advice for these young students aspiring to do mathematics?
Firstly, let me say something about CBS, the Center for Excellence in Basic Sciences. In India, very early after the independence, we had these IITs, and in the recent years, they also increased their number substantially and so on. But for basic sciences, there was no similar boost. So in effect, and this was realized, and then I mean, from this point on, of course, you would recall that there are many ICERs were established, and then similarly, the Department of Atomic Energy also felt that it should do its bit, and then they set up two things. First is NICER, which is Bhubaneswar, and another thing in collaboration with University of Mumbai, and that is the UMDAE, so University of Mumbai and Department of Atomic Energy Center for Excellence in Basic Sciences. The first batch was started sometime in 2007. So here the idea there is something like IIT at the stage where students are completing school at 12th. You may get a selected bunch of students, train them further to make them and groom them as scientists or mathematicians and so on. So this activity has been going on since 2007. I think the mathematics came maybe a couple of years later, but something like that. And for various reasons, they're kind of fixed size maintained until now. So though I think the larger size would have been beneficial, somehow it turns out that there's a sanction of 60, so around 60 students every year we get admit through a selection process. And then they so far the system was that they get training in all the four: physics, chemistry, biology and mathematics during the first year, and at the end of the first year they make a selection for pursuing further studies from one of these topics. So, I mean, of course, for various reasons that you may not have difficulty in grasping, mathematics is not one of the popular subjects. We usually get only about 4 to 6 students for a batch, and so that's how it has been running so far. But nevertheless, some of the students have been very good, and they have went on to do further studies in the US and done good work and so. Anyway, so yeah, I joined there in 2017, and I also had the good fortune of having some very good students during the period. Though as I said, it being not the popular choice for students, it's not always that sort of reflects in the students that are left also. Okay, so but fortunately, with the new educational policy, the scheme is changed. So now the the subject of pursuit is to be chosen right at the outset, which is a good thing to have happened, because at the end of 1 year you are left with only somewhat willy-nilly students. Some of them remain, and whereas here they are, I mean, making a conscious choice right while entering that they are going to pursue mathematics. Now this is our first batch, and so it also had the effect that So out of the total of 60, we actually get about 15, close to 15 students. So we have a sizable batch, and that will also have its advantages of quality in terms of quality and also maintaining harmony. I mean, the fact of being able to interact with fellow students and so on a substantial scale also seems to be an important thing to happen within the area. So I'm very hopeful that this program will flourish with this new development.
And some specific advice, the audience will consist of some students who would like to hear your views on how to do mathematics or how to pursue.
Yeah, specific advice or comments or to a few words, so to say, is doing mathematics is something to be enjoyed. I mean, it's like doing being a novelist or being being a poet, and you do it more for the enjoyment. And in fact, the monetary prospects are much better compared to being a poet or literature. I mean, so in that sense, it's a very sustainable, on the one hand, very sustainable occupation, which you can sort of manage a good life. You can also hope to go around the world, see many things, and participate in activity, the academic or the intellectual activity on a much larger scale. So, of course, one has to worry about the life prospects and so on. But as I said, they are quite satisfactory, if not, I mean, so it's satisfactory, and the advantages that I mean, you are much less tied to any particular commitment as in a job. I mean, that in terms of delivery and so on is also a psychological advantage. So I would say people with interest and ambition and so on should pursue science, and in particular mathematics and while doing that, it ought to be done more for enjoyment, and at the same time keeping one eye on the feasibility in terms of practical life, but nevertheless focusing on the urge to succeed in finding new things. I mean, the accumulation of knowledge is the thing which sort of distinguishes the human species, and it's the sense that what you are going to say is going to, what you might say is going to be of consequence for substantially longer period is a greater source of satisfaction than many other aspects, I would say.
Pursuing quality mathematics.
Yeah. The thing that ideally needs to happen, which actually I'm not sure what happened in my case, is at the same time as you are producing work, you need to develop a sense of what is worthwhile, what is good, what is more lasting, what is that one should care more about. And if you consciously keep in mind both these aspects, what is interesting and what it would serve for. So, and sort of putting together a variety of things that you will together, then of these things, one can hope to succeed better.
I've been aware of your concern for women empowerment, which is an issue close to my heart. Could you please tell us a little about your contribution in this respect?
Yeah, there's absolutely no doubt that the women's participation in intellectual activity and in particular in mathematics has been much less than it should be. I mean, there's no, there's particularly in the case of mathematics, so which is less constrained in various respects like lab work and this and that. There ought to be high representation. Now, of course, what exactly one can do about it has been a sort of enigma, so to say. Now, in the national board, of course, we introduced various provisions and so on, and try to propagate them. But I mean, there are limitations to which they can be made useful also. And I think now you have considerable funding support from the for this IWM and so on. In some way, I think it was a development coming from the previous development at a mature stage. I mean, earlier, of course, we only funded in a limited way, but now that has gone on. So it's a rising graph, which is very welcome. Now, perhaps more should happen, and more women should be seen in our institutions, and at in top echelons. I mean, not just as students, but also professors. Of course, now quite a few interesting things have happened. I mean,
there are 2 women Fields medalists in recent.
Abel Prize also.
Abel Prize
so, but this is still just the beginning. I mean, I don't think there is room for being complacency of any sort. But at a personal level, what one can do for this is somewhat limited. I mean, of course, as you know, I have had 3 women students, which is a fair proportion. So,
both your daughters and wife were mathematicians.
My daughters made their own choice, and I don't count it.
Thank you, Professor Dani, for this wonderful interaction.
Thank you.
And
yes, thank you also for your many great contributions to mathematics, and may they continue in the years to come.
Yeah, thank you.
And I'm sure this will inspire young students
and mathematicians such as ourselves
to
work harder.
Yeah, right. Thank you.